Zbyněk, you could take control of my computer now.
Okay, so next slides, please.
Okay.
Okay, thank you very much. So, hi to everybody once more. My name is Zbyněk Hrkal. I'm responsible for the monitoring program, and I am from the Agriculture University from Prague. So, the monitoring program of the boDEREC project have two main objectives. The first is verify occurrence of pharmaceuticals and other PPCP substances in Central European water environment. And to obtain the results will serve, inter alia, to compare the efficiency of PPCP removal using different drinking water production technology. Please, next slide.
Yes.
Yeah. Each participant have an own pilot area. So that means boDEREC project have in total 8 pilot areas. That means the Germany, because we have 2 participants from Germany, have a 2 pilot area, Neustadt and Dresden. These 8 pilot areas cover very large scale of the natural, social, and economical conditions, and differs also by the total scale. You can see that the largest pilot area represents the Po River in Italy, which covered practically the overwhelming majority of the North Italy. From the other hand, some pilot areas are relatively slow scale or slow territory. Next slide, please.
Of course.
As I said, the boDEREC project pilot sites are different as far as from the point of view the scale, but cover practically all the typical land use features of the Central Europe, and also the geology, typical features of the geology of the Central Europe. We tried to found such pilot sites system that is able to cover also different sources of PPCP. When we summarize all the sources of PPCP in our pilot sites, we can sum up that we have sources from agriculture, sources from settlement, from leaking sewer. One of the most important source of PPCP are wastewater treatment plants, which, according to our experiences, have a relatively low removal efficiency. Then one of the also very important source is the interaction between surface and groundwater. And in some specific cases, for example, the Czech pilot sites in Kárany have a very specific source of pharmaceuticals, which is represented by the hospital facilities. And as I said, one of the important objective of the monitoring is to assess the efficiency of the drinking water production technologies. And if you sum up which kind of water production technologies we use in Central Europe and in our pilot sites, we can say that there is a two principle. First is representing by the pumping from boreholes, that means groundwater. Groundwater which come from particularly from the fluvial sediments, from some part in sedimentary basins, and from karst. The second most important source of the drinking water, the raw water, came from the withdrawing surface water from rivers, and two pilot sites have some very specific kind of the drinking water production technology, riverbank filtration and managed aquifer recharge. That means it's Dresden and Kárany from Czech Republic. Next slide, please. As far as the frequency, in the majority of the pilot sites, the frequency of the sampling is between 2 and 3 months per year, and this table summarizes the number of samples per year. So that means we have an idea to take approximately 260 samples. But I would like to point out that the total number of the analyses should be much more higher, because this table summarizes only the analysis which is covered by the budget of the boDEREC program, and some participants, for example, our Poland friends, exploit also their own financial sources, and that means that the total number of the analysis of the samples will be much more higher. Next slide. We are only on the middle of the sampling campaign, so that means that I can show you the final results. For this reason, I select from the preliminary results only two interesting examples. The first one is a comparison of the situation on the rivers in the Central Europe, in the pilot sites, which serve as a source of the raw water for the drinking water production. This table shows you the typical situation in the Central Europe on the 7 rivers, Central European rivers in our pilot sites, and this table is selected by the level of the pollution. On the left side, there are the 4 rivers which is most polluted: Isar, Brinica, Jizera, and Elbe. And on the right side, there is a 3 rivers: Weidhofenbach, Po River in Italy, and Cetina, which is relatively in the very good state, which is relatively clean. But what is very interesting, that this polluted river, in spite of the fact that there is no interaction between, for example, Isar and Elbe, the quality of the river is more or less the same. The different color represent the frequency of the different pollution in the surface water. The red color means that this specific pollution is found practically in all rivers, with the exception of Weidhofenbach. The highest frequency is in case of metformin and benzotriazole, which is the typical kind of the substances which we can find in all rivers in Central Europe. From the other hand, on the bottom of this table, there is some specific pharmaceuticals, which is represented by the white colors, which is typical for each of specific river. Next slide, please. The second slide show you the comparison of two identical technology, which is artificial recharge. I mentioned that we have two specific sites, Dresden in Germany and Kárany in Czech Republic, which use the identical, very specific, identical drinking water production technology. That means riverbank infiltration and artificial recharge. And when we compared the first preliminary results from Dresden and Kárany in artificial recharge technology, we received practically identical results. You can see in the previous slide that the quality of the river Elbe and Jizera are more or less the same, but the results from the output are also the same. So that means that the efficiency of the removing of these pharmaceuticals are both in this technology practically the same. The next slide. And my final slide, it's the goals for the final goals of the monitoring. So that means we have 1 year of the sampling, and that means we would like to finish all the sampling, and we will have relatively enough time for the assessment of all the data. We would like to analyze temporal and spatial changes of all the pharmaceuticals and PPCP substances, the behavior in sources for the drinking water production. And finally, we would like to analyze the efficiency of the PPCP removal by different technology of drinking water production. So that means it will be the final output of the monitoring program. So thank you very much for your attention.
Thank you, Zbyněk, for your presentation. Yes, I need to hold my presentation.